Summer, San Diego's miles of idyllic beaches draw hordes of families and tourists, but this year, other hordes are lurking just offshore. Thousands of real, menacing beasts from the deep. ABC's Mike Von Fremd reports on the invasion of the monster squid.
Swimmers are coming face to face with a vicious visitor, jumbo flying squid with razor-sharp beaks, some as long as 7 feet. Recreational scuba divers were the first to bump into these beasts. Roger Uzum swam out recently to get a closer look.
I don't think it's sad, really.
Well, it started out down a dirty road. Started out all alone.
But how and why do these marine creatures take to the sky? While only a few squid species have been recorded taking flight, most squid are alike in the way they traverse the ocean. The outside of a squid's body is a massive tube of muscle called the mantle. Water enters that tube through small openings around the squid's head. Then, muscles clamp these openings shut, and the squid forcefully pumps the water through the base of their body. In practice, this makes the mantle a miniature jetpack, propelling squid through the water at 10 kilometers per hour. This process is also how squid breathe. Squid gills rest inside the mantle and siphon oxygen from the water being pushed past them. With gills full of air and a mantle full of water, squid can outpace predators and pursue their prey. Or, in the case of some species, they can smash through the ocean's surface and attempt an epic flight. Without the resistance of water, a squid's acceleration is the same as a car, going from 0 to 100 kilometers per hour in just over a second. At speeds of 40 kilometers per hour, squid quickly generate aerodynamic lift. But to stay in the air, they'll need something like wings. Fortunately, our soaring cephalopod has a plan. Squid tentacles are muscular hydrostats, meaning the tissue can be held firm by muscle tension. Splaying its tentacles in a rigid formation, the squid transforms them into flexible wing-like structures that stabilize its flight. At the opposite end of its body, 2 fins typically used for gentle swimming find new purpose as a second set of wings. And by folding these fins down, a squid can streamline itself and dip back into the ocean. There have been too few observations to establish what a squid's typical flight trajectory looks like. Based on their flying speed, a 10-centimeter squid could hypothetically launch itself 6 meters above the water. But from what scientists have seen, flying squid tend to glide low, keeping close to the surface. This trajectory allows squid to cover the most horizontal distance possible over a typical several-second flight. It also makes it easy to dive back into the water for more fuel, or to make a quick escape from predatory birds. But why do squids fly at all? Leading theories suggest that flight is an escape behavior, as flying squid generally seem to be fleeing a nearby predator or ship. Other researchers think their flight may be an energy-saving migration strategy, because it takes less energy to move quickly through the air than through water. However, it's also possible that learning to fly may be a vital part of surviving adolescence. Young, smaller squid can potentially fly faster and farther than their larger relatives. And since adult squid tend to cannibalize juveniles, soaring above the surf can help ensure these young squid will live to fly another day.